we're going to put an RJ45 Ethernet connector on this fiber optic cable for communication purposes. The tools that we are going to need for this job are a razor blade, a pair of wire strippers that can go up to 8 gauge, a pair of flush cuts, and a pair of channel locks, and that should be all that we need. Alright, so now that I've opened up the pack, we're going to begin with stripping our wire. So we want to go about 2 inches, maybe 2.5 inches to make our first initial strip. There's a metal shielding for grounding our connector underneath this green shielding of wire. So it's not always easy, but we don't want to nick that metal shielding. Now that we have about 2.5 inches of our metal shielding, we want to start to compact it all down with our fingers by giving it a nice little twist. We want about a 1/4 inch, between a 1/4 inch and a 1/2 inch of that compacted metal shielding exposed before we cut off the excess with our flush cuts. After we cut off the excess with our flush cuts, we're going to peel back this foil that's underneath the metal shielding and give it a twist so that we can also cut that with our flush cuts. Underneath that we have our wires that are covered in this thin piece of rubber. So we're going to grab our razor blade and give it a very light score with our razor blade. A very light score, as to not cut the wires that are underneath. Once we peel that back, we want to cut that off with our flush cuts as well. Underneath that, we have a piece of plastic that we want to get rid of. And finally, before we get to our wires, we have a little tiny piece of rubber inside of all our wires that we don't need, so we're going to cut that away also. Now the first part of installing our connector after we have stripped our wire and gotten to this point is to put our base of our connector on first. After we put that base of our connector on, we put the second part of our base of our connector on. Now we're ready to put the third part of our connector, which has a color coding on it as to which wires we want to put in which hole. So now that we've gotten to this point, we want to stick our 2 top wires into the 2 top holes. So we're going to stick our orange in with our orange, our blue with our blue, and to line the rest of our holes up with the colors of the wire, we need to give it a little twist because the color coding inside the wire doesn't quite line up with the color coding on this connector. So we want to stick our white in with our white, our yellow with our yellow, and we've gotten that far. Now I'm going to grab my channel locks to get a nice tight grip on all 4 of those wires so that I can firmly secure this connector and slide it all the way down next to that grounding shield that we snipped back. Now that I know that it's nice and tight, we're going to get our flush cuts and make a flush cut on all 4 of these wires at the base of our connector. Now that that looks flush to me, we can then grab the tip of our connector and give it a nice shove, because these are self-crimping connecting pieces, so they will score the wires when you insert them into this piece. And you can give it a nice firm push, but there is a third part of this connector that is mainly for crimping. And if you slide this connector in to this plastic insertion and give it a nice press, or you can use your channel locks and give it a nice press and squeeze, the angling inside this crimping device crimps it for you. And now that connection is complete. Now we grab this part of our grounding shield for the connector, because when we slide this up underneath this part of our connector and push down on our grounding shield of our wire, now this connection is grounded. We can grab the bottom part to this connector and pinch in our two sides right here, because there's 3 little holes right there on that part of the connector on both sides of the connector, that these little 3 slits are going to clip into, and you will hear the clip when you do it right. So when I push it in there, I can kind of hear all 3 clip, so I know that it's secured. Sometimes you got to play with it a little bit, but you can see that those 3 notches and those 3 notches all clipped in, so that is now secure. The last part of this process is to push this base all the way up. Sometimes you got to jiggle it around and play with it all the way up to the beginning. And finally, the final step to this process is to screw the base onto our connector. So give it a couple good screws till it's tight. And the process is now complete. We have just completed adapting an RJ45 connector to the end of a fiber optic cable for Ethernet communications. Okay, so today we're going to show you how to check the continuity between an RJ45 Ethernet cable to see if it is good or if it is a bad cable. For this, we are going to need a tester that is able to test the continuity for the Ethernet fitting itself. Then you're going to need your cable that you're testing. In front of you, I have a good cable that I made and a bad cable that I made, so that when we check both of them, we could see what we're looking for in the good cable versus what we don't want to see in a bad cable. The next step is going to be to plug in our adapter for the RJ45 into one end of your Ethernet cable. The next step is to plug the other end into the RJ45 adapter of the tester itself. Then we're going to turn the tester on. Next, we are going to go over to the continuity section of our tester. Then we are going to press OK. Now we're ready to check continuity. We press OK again, and what we're looking for is leads 1, 2, 3, 6, and ground. And that is what we have here. So this is a good cable. That's what we're looking for. When we're done, we're going to unplug it, and we're going to shift on over to our other cable, the cable that I wired that is not good, so we can give you an example of what you might see if you have a bad Ethernet cable. So we're going to repeat the process. We're going to plug one end into our adapter, and we're going to plug the other end into the RJ45 slot of our Ethernet tester, and we're going to press OK, and we can see that there's kind of a debacle going on here. We don't have leads 1, 2, 3, 6, and we have 6 and we have ground, but there's a crossover between 1 and 3 somewhere in this cable. It says that we have lead number 2, so we have 2, 6, and ground, but 1 and 3 seem like they might be crossed, so this is a bad cable. So at this point, now that you know that you have a bad cable, you're going to have to make a repair. You're either going to have to replace the cable altogether, or you're going to have to replace one or both of the ends that are in the cable. After doing so, you would want to check this again to make sure that you fix the problem And if it didn't fix the problem after replacing both ends, I would say just replace the whole cable altogether.